Start. Hi friends, this is Yamuna studying 10th standard from TSWRS GRC College, Nadgudem at Suryapet. Today I am going to give you a presentation about paradox of Gabriels Horn. Are you ready friends? Yeah, okay. Now let's look at the slide. Yes, here we are having the objectives of today's topic. Friends, here the first objective of the topic is define paradox. And second, historical importance of the Gabriels Horn. At last, finding surface area and volume of solid geometrical figure Gabriels Horn. So friends, before going to the topic, let us have to know how to calculate the surface area and volume of some 3D shapes. So friends, here we are having the definition of surface area and volume. Friends, now first discuss about the surface area. Friends, what do you mean by surface area? Yes, the surface area is nothing but surface of a three-dimensional figure including top and bottom is called the surface area. It means sum of the area of all the faces of a three-dimensional figure is called surface area. Have you getting my point, friends? Yeah, okay. Now, let us discuss about the volume. Friends, volume is nothing but the number of cubic units it takes to fill a three-dimensional figure is called the volume. Friends, so it means some amount of space occupied by a three-dimensional figure. So that is exactly a volume. Friends, now let us consider an example of cube to find surface area and volume. So friends, yes, here we are having the diagram of cube. Friends, what do you mean by cube? Yes, a cube is a three-dimensional figure which is bounded by the six square faces is called a cube. So friends, here we are having the example of cube. Yes, it is a Rubik's cube. So friends, now shall we count the how many faces are there? Yes, now we can count. 1, 2, 3, 4, 5, and 6. So the cube having 6 faces. And next, now let us count how many edges are there for the cube. Yeah, shall we count? Yeah, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So friends, here having cube has 12 edges. And next, let's count how many vertices are there. 1, 2, 3, 4, 5, 6, 7, 8. So friends, the cube having 8 vertices. So here we can say that the cube have 6 faces, 8 vertices and 12 edges. So friends, here we know that the area of the square is side into side. If side is considered as A, then the area of the square is, yes, exactly, A square. Similarly, the cube having 6 faces, right? So the surface area of the cube is 6a square. So friends, now coming to the point of volume of the cube, we can easily find the volume of the cube by knowing the lengths of its sides. So for example, if we can imagine that the length of a side of a cube is A, then the volume will be the product of the length, breadth and height. So friends, here we before discuss that the length of the side of a cube is A. So here the volume of the cube is length into breadth into height. So here A into A. So friends, A cube. So by this we can conclude that the volume of the cube is A cube. So friends, now let us discuss about the another three-dimensional figure. Yeah, friends, what the figure called? Yes, it is a cuboid. Friends, what do you mean by cuboid? Yes, a cuboid is a three-dimensional figure which is bounded by the six rectangular faces is called the cuboid. Friends, a little bit difference between the cube and cuboid. That is the cube having all faces in the shape of square, right? So the cube having all faces are in square shape. But as in cuboid, for example, yes, this is a textbook. So it is an example of the cuboid. Once look at this. Yes. Now we can count how many faces are there for the cuboid. Yeah. 1, 2, 3, 4, 5, 6. And next, edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So friends, the cuboid having 12 edges. And next, we can count how many vertices are there. 1, 2, 3, 4, 5, 6, 7, 8. So friends, as we compare it to the cube and cuboid, the both are having same number of vertices, edges and faces. But what about the shape of the faces? Yes, they are not similar. The cube having all faces in the shape of square. But as in cuboid, the all faces are in the shape of rectangle. Friends, coming to the surface area of cuboid, before going into the concept of the surface area of the cuboid, let us denote the dimensions of the cuboid, the which are length, breadth and height. Friends, surface area of the cuboid is sum of the area of all its six rectangular faces. So that is which is given by that. So the surface area of the cuboid is 2 into length into breadth plus breadth into height plus height into length. Have you clear, friends? Yeah, okay. Now, let us discuss about the volume of the cuboid. Friends, here we know that for any three-dimensional figure, the volume is area of the base into height, right? So here the cuboid having the six rectangular faces. So let us consider it as a base. Since the area of the base is length into breadth. So why? Because the cuboid having all faces in the shape of rectangle. So the area of the rectangle is length into breadth. So by this, we can conclude that the volume of the cuboid is length into breadth into height. So friends, have you clear about the cube and cuboid? Yeah, okay. Now we are going to measure the surface area and volume of Gabriels Horn. Friends, but it has some contradictory. This contradictory is popularly known as the paradox of Gabriels Horn. Friends, first let us know what is paradox. Yes, once look at here. Yes, here we are having the definition of paradox. A paradox is a statement in which it seems that if one part of it can true and the other part of it cannot be true. It means if we take, for example, one statement. So the some part of the statement of it can true, but other part of the statement cannot be true. So that is a paradox. Friends, to understand the word paradox briefly, let us have a look about some statements. Yeah, here we are having some paradox statements. Yes, friends, what's the first statement? Yes, social media disconnects us from each other. Friends, here, as per the statement, social networking sites allow us to communicate much more with people than ever before. We can talk to our friends without leaving our homes too. And we can do our works without leaving our homes in this pandemic situation, right? So hence here, it is one side acceptable truth of social media. But as per recent survey, those who are using social media too much are becoming isolated and they are facing some mental and emotional issues. So friends, it is also true. Here, we clearly observe that the one part of the statement is opposing the other part. So friends, another similar statement is here. The only constant is change. Friends, and next statement is also here. The only certainty is uncertainty. Friends, if we observe these two statements clearly, first statement, the only constant is change. Here, constant, change. These two words are antonyms. Antonyms means nothing but opposite words. So, these two are opposing the one another. So, it is also true. And next, certainty, uncertainty. Friends, here also we can observe that the one part of the statement is opposing the other part. Now, similarly, think about these statements. The first statement, the pursuit of happiness will make you unhappy. And next statement, save money by spending it. Friends, here save money by spending it. As per the statement, government spending more money to provide equality education to the underprivileged students under TSWRS, right? So it is a strengthen to the students' future and it can lead to the economic growth of our country in future. Friends, we the people having goals. So we have to achieve the goal by the good education. And first of all, we need the good infrastructure. So all this work done by only the money, right? Then how can we save money by spending it? So here also, we can clearly observe that the one part of the statement is opposing the other part. So friends, here we are going to look some paradox statement about zero. Friends, what do you mean by zero? Yes, zero is nothing. Initially, it's not having any value. But zero makes too much difference when we kept after any number. For example, put a zero after number 2, then what will you observe? Yes, we can observe that the value of 2 increases to 20. So here we can say that if we put nothing at a certain place, it has something. So friends, these are some paradox statement about zero. Friends, now look at the next slide. Yes, here the word the symbol signifies. Yes, this is a symbol of infinity. Friends, what do you mean by infinity? Yes, exactly. Infinity is nothing but endless. It means it's not having exact value. It's just moving on. It's not having any stop. But mathematics itself measures and calculates something. For example, natural numbers. Friends, what do you mean by natural numbers? Yes, natural numbers or counting numbers from 1, 2, 3, 4 to infinity. So in this series, we can't assume the last number, right? Is it easy to assume the last number of this series? No, we can't. Why? Because the natural numbers are infinity. They are not having the exact value.
Please unmute. Unmute. Yamuna, Yamuna, can you please unmute yourself?
Be true. Have you understand? I hope you understand the word paradox correctly now. Okay, friends, now we are going to learn some history about the Gabriels Horn. Yeah, are you ready, friends? Yeah, okay. Now, yes, once you look at the slide, yes, it is a figure of Gabriels Horn. Friends, the name Gabriels Horn was refers to the Christian tradition that identifies the Archangel Gabriel who blows the horn to announce something which is associated to the divine. Friends, in Abrahamic religions, Gabriel means God is my strength. So, friends, yes, next figure, yes, that is a figure of Evangelista Torricelli. Friends, do you know that Gabriel's horn is also known as Torricelli trumpet? Friends, the properties of this figure were first studied by the Italian physicist and mathematician Evangelista Torricelli in the 17th century. Friends, this is the history behind the Gabriel's horn. So friends, now here, once look at here. Yes, here we are having the 3D figure of Gabriel's horn. Friends, as I before said, we can calculate the surface area and volume of this 3D figure of Gabriel's horn. Yes, friends, here we are having some mathematical definition. Friends, the Gabriel's horn was formed by the taking a graph of y is equals to 1 by x with the domain x is greater than 1 or equals to 1. Before the invention of the calculus Cavalier's principle was used to explain the paradox of Gabriel's horn. Friends, do you know what's the Cavalier's principle? Yeah, okay, I will tell you. Cavalier's principle tells us that if two figures having same height and same cross-sectional area at every point and along the height, then the two figures must have the same volume. So friends, that is a Cavalier's principle. So friends, it actually the Cavalier's principle was originally called as the method of indivisibles. It is easy to explain this phenomena by using calculus. Friends, so as we before discussed, the Gabriel's horn was formed by the taking the graph of y is equals to 1 by x. Friends, now let us find the surface area and volume of the Gabriel's horn. Now once look at this. Yes, it is the Gabriel's horn prepared by the chart. So friends, here we can see the Gabriel's horn. It is in the shape of here like this. So friends, do you want to see the real instrument of the Gabriel's horn? Yes, it is the real instrument of the Gabriel's horn. Friends, this is the Gabriel's horn. So it is actually, but friends, where do you see this Gabriel's horn? Yes, we can see this in the occasions. So it is a Gabriel's horn, friends. So here, this is a Gabriel's horn. Friends, now we are going to find the surface area and volume of Gabriel's horn. Friends, now first we will find the surface area. Are you ready? Yeah, okay. To find the surface area of Gabriel's horn, we assume that trumpet make into slices. And here we need to find cross-sectional area of every slice and sum up it. Then it will go infinity. So that is integration limit 1 to infinity 1 by x dx. So here it will go diverges. Friends, we already know that diverges means it will go for infinity, means it cannot meet at a point. So here it will go diverges. So friends, so that's why we can say that the Gabriel's horn has the infinite surface area. Yes, now only we see that. So it is the diverging. So friends, here we can say that the Gabriels Horn has the infinite surface area. Next friends, now look at the next slide. Yes, here we can find the volume. Okay friends, same process is here, but for the volume, integration limit 1 to infinity pi to dx. So friends, by solving this problem, we can get the answer pi. Friends, as we before discussed that, the Gabriel's horn surface area, if we observe that it will go infinity, it is diverging, right? So it's not having exact value. So that's why we can say that it has an infinite surface area. But in this volume, we are getting the exact value that is pi. So here we can say that the Gabriel's horn has a finite volume. So that is we are getting the exact value that is pi. So friends, hence we can prove that the Gabriel's horn has the finite volume and infinite surface area which has contradictory. Friends, contradictory is nothing but one part is opposing the other part. So friends, here we only just do that just that surface area is infinite for the Gabriel's horn and finite volume for the Gabriel's horn. So friends, here I have a question in my mind. That is, how can this Gabriel's horn inner surface to be painted? Yes, exactly. So that is painter's paradox. Friends, now let us know about the painter's paradox. Yes, friends, to explain this phenomenon, painter's paradox, now, yes, we have to know that, we know that the inner surface area of the Gabriel's horn is infinite, right? So there is infinite paint is needed to paint the inner surface of the Gabriel's horn. But the Gabriel's horn has the finite volume. So for this, we have to put some amount of paint into this horn and then emptying it. So it is a way of painting that should be painted to the inner surface of the Gabriel's horn. Have you clear, friends? So if we pour some amount of paint into this horn, so it has a finite volume. So yes, we have to pour some amount of paint into this horn and then emptying it. So it is a way of painting so that inner surface area of the Gabriel's horn. Have you clear, friends? Yeah, okay. So friends, if you have any doubts, you can ask me.
Okay. Thank you so much, Yamuna. So I would like to ask you, how does Gabriel's horn have a finite volume? Can
So
you hear
thank you
me?
for asking me this question, ma'am. So here, minus 1 plus 1 is equal, minus 1b plus 1 is equals to pi into 1. So here pi into 1 is equals to, we are getting the answer pi. Hence, even though the horn will extend out along the x-axis, and then it will, the improper integral can converges at a point. So hence, the Gabriel's horn has the finite volume.
Okay. So what is this Gabriel's horn was used for?
Ma'am, this name, Gabriel's horn, was refers to the Christian tradition that identifies the Archangel Gabriel as the angel who blows the horn to announce something on Judgment Day, which is associated to the divine with the finite.
Okay, thank you. And also, as you explained, what are the few attempted resolutions encountered on the interior of the horn that cannot be paid with a finite amount of paint because its a surface area is infinite. So, what are the few attempted resolutions encountered on this statement?
Thanking you, ma'am, for asking me this question. So you can't paint the horn with some amount of with some paint. It would take forever. So here, how long? It no matter how long you can paint the inner surface of this into the horn, no matter. So it can take forever. So we can't paint the inner surface of this Gabriel's horn. Likewise, it will take forever to paint out. And also, if you paint means there is some still parts are there in this Gabriel's horn. Why? Because it's having infinite surface area. So there are still some parts in the Gabriel's horn while you're painting also.
Okay, thank you, Yamuna. We are done.
So thank you, friends. And also, I would like to thank the Secretary, Sir, Dr. Paris Ravin Kumar, Sir, who has given me this golden opportunity. And also, I would like to thank my Principal, Sir, Bikshmaya, Sir. And also, I would like to thank my mentor teacher, Sujata Ma'am. And also, I would like Renuka Ma'am, Lalita Ma'am, Shalika Ma'am, Manikyamma Ma'am. So, who guided me to do this successfully project? So super student program. So thanking you one and all. So thanking you friends for listening this class very carefully. Thank you friends.